Yeah, do you want me to go ahead and share my screen?
So good afternoon, and thank you for joining us for another segment of the Jain Irrigation Training Series. I'm Richard Restuccia, your host and Vice President of Water Management Solutions at Jain Irrigation. And today we're going to be talking about a subject that comes up no matter what circle I'm in, whether I'm dealing with professional growers, farmers, the Hort Society meeting in San Diego, the Master Gardener meeting in San Diego. People want to talk about cannabis and hemp. And the opinions on it vary greatly. Some people think it's a solution for tax revenue. Others think it is a great solution for pain management. Others don't appreciate the subject at all, but still want to talk about it. So it's definitely a interesting and talked about subject. Today we've got Michael Derewenko, our Irrigation Solutions Manager for Cannabis and Hemp, with us today. He's created a guide to irrigating indoor cannabis, and with a crop that is so new for relatively most people. This guide is hugely helpful. You can take a look at the guide and pretty much have a step-by-step process for irrigating cannabis. So I want to say welcome, Michael. Thank you for joining us. If you've seen Michael before, you know his presentations are informative and interesting. Michael's got a long background in irrigation. He has traveled the nation extensively for the past 4 years, working with cannabis growers all over the US, and has really learned a lot. And we really appreciate that you're willing to come on today and kind of share this knowledge with us. So thank you, Michael.
Yeah, thank you, Richard. Yeah, that's all completely accurate. I've seen a lot out there, and we've seen the wrongs, we've seen the right. So hopefully we can get everybody pointing in the right direction when it comes to specifying products and working on design and taking over these what can be a substantial amount of work.
Yeah, well, certainly we don't, we know that we don't really have a lot of data or information or documentation over the last 100 years on how to grow this. There's some people out there with some experience, but they're pretty quiet about their experience, which I understand. So again, I really appreciate this. So Michael, I'm just wondering, like I said, everywhere I go, people want to talk about this. Can the average gardener, the average person, actually grow cannabis? I know in places like California, it's legal to have some plants, but is this something the average person can do?
From a legal standpoint, or from a just a skill set?
A skill set standpoint.
From a skill set, I mean, I think anybody in this country could probably grow whatever they really wanted to grow if they put the time into it. I think there's some time and training that needs to exist. I think, I think we try to put a pretty solid subset of variables together that people need to take into account before maybe they consider whether or not they can do it, or whether or not they have the time to do it. I'm sure that's probably the most valuable aspect of this. And we could tell from the quality of the crop and the yield that growers get, how much time and priority they've put into it. And so I think everybody could potentially do it. It's just whether or not you want to do it. Now, you also have to remember the main reason we're growing hemp and cannabis is to make money. So if you're growing soy to eat it, that's great. If you're growing hemp and cannabis and then you don't want to partake in the use of hemp and cannabis, you're not going to be able to sell it. So now you're just growing, a big smelly plant that is maybe more of a talking point at a party than it is a monetary value.
Yeah, interesting. So, and then the other thing that comes up all the time is, can you grow this indoors, outdoors? What's the benefits of each?
So as we talk about, and I've talked about extensively, anytime we can put consistency into a system or any form of growing operation, it's going to be value added, not only from a time standpoint, but from a production standpoint. And so I think, anytime you can control as many variables as possible, you're creating a consistency. And so if we can pull that indoors and eliminate, those things that we don't know, cloudy days and, the uncontrollables, then I think you're better off at value. And so that's why the majority of high growing growers actually are moving stuff inside. It's to control the variables and ultimately to report on what you're growing is a big one. Keeping track of water, keeping track of nutrients is way easier inside.
Yeah. That's interesting, right? I mean, that's kind of the ideal situation to be able to control the environment instead of having to react to what Mother Nature throws at us. So I just wanted to remind everybody we've got the Q&A and chat open today. So if you have some questions, please shout them out to us, and I'll get them into Michael as appropriate as we go along. So Michael, I'm dying to have a look at your guide. Can we take a look at that now?
Yeah, so I want to preface this, which is like I did the hemp guide we created. One of the main reasons and motivations to do this was to kind of put all the issues that we and the challenges we've seen on paper, and then the product solutions we can provide, or just the industry in general can provide, the wherewithal and the support needed from our sales team that we can provide, is to kind of put it all down. And so while we may be the experts in irrigation and providing distributing water to a plant, we are not growers of these plants. And so we have a long list of growers we can get people in touch with if they want kind of the proven technology, or they want to get a hold of somebody for more insight on at a project level or a farm level, they can. But when it comes to the design and specification of irrigation products for this crop, then I think people look no further. We have every solution you need. And so we put this on paper.
That's a really good point, Michael, right? Especially in this area. It's, when I think of wine grape growers, they have a lot of special techniques that they use that they believe gets the right grape for wine. And I think the cannabis growers are the same way. They have their proprietary fertigation routines, or how much water they give and when. And so you're right, this isn't something we do. We provide the components to get the water to the plants. They decide how much, when, and what goes in the water.
That's right. That's right. We provide the options, which to me is way better. That way you're not stuck with, a boxed solution. This is something that you can adapt to. And then that's why that follow-up sales support is so necessary, because once you've installed the product, unfortunately it's not set it and forget it. There is some follow-up support needed, and hopefully, our teams can provide that.
Yeah. So, okay, great. Well, let's have a look.
All right, so how are we doing there?
Yeah, it looks great. That's that's a great photo. I think you even took that one yourself, right?
Oh yeah, everything in here is stuff we've shot.
Yeah, I was gonna say, that's probably something I can say every photo in here is something you took yourself, right?
Yeah, it's a little easier to design support, collateral around your own imagery, for sure.
Yeah.
Same with the opposite.
Yeah. Is this a typical system that we're looking at right now? I mean, is that, a pretty normal irrigation setup for indoor cannabis?
So there's a little bit of overkill here. The reason that this exists, and this creates some confusion with people that see it, they were only running one side of the table at a time throughout the year. So they're switching out larger pots and then smaller pots and medium-sized pots. And so they were able to, so the octobubblers, technically there's double to a table that there should be. That's why the spacing looks so tight. Everybody always comments on that. But the reason for that is, there's ball valves at the end of each line. And so they're running one line for a particular nutrient, and then the other line for a particular nutrient, and they're running different pot sizes throughout the year. So they wanted to have complete flexibility. All these benches are rolling benches. So they they go across the aisles in the middle to capitalize on any square footage that may be lost because of the fire breaks on the walls. So all these benches go together under the lights. And one of the things they wanted was to control the water to each table down to, where they could have two things running at once. So it's a little bit of overkill, but once you hear why it's installed like that, it makes sense.
Yeah, it definitely does. In fact, I kind of like the sophistication there. So what are we looking at here? We're looking at octobubblers, some tubing. What else?
So we, a while back, we make these manifolds that go right below the octobubblers. There's just a ball valve underneath with, some threaded risers. And they come in all different sizes, so you can order kind of like a kit. But as you can see, there was 12 rooms of this size. So it can be quite the process to screw all these components together. So we figured, once again, to add consistency to a design, from a design standpoint, we'll provide the exact same riser scenario and ball valve with an octobubbler on top. And now you have a pre-assembled solution where you're just having somebody screw them into a T, and it just saves all that time, because putting Teflon tape on and putting those together, is just a time-consuming process. And so they're looking at a pressure compensated octobubbler manifold on top, and then it's connected to the pre-assembled manifold below it.
Yeah. That's so interesting. One of the things that came up earlier or last week on one of our lunch and learns was labor is getting so expensive that growers of all kind have to adopt to some technology. So I would think that pre-assembled kits are going to be pretty popular going forward.
Yeah, I mean, we hope so. Everybody's been trying to put an irrigation system in a box for a long time at every level. It is, but there you can take small chunks out of it. The same reason we sell pop-ups with swing joints already installed. I mean, you just have to it's slow drip zone control kits, valve manifolds. You can buy all these things pre-assembled now. Ultimately, everything will become, it will become more kitted, and we're fortunate with indoor growing and even some hemp applications, we can provide a kit as a manufacturer. So it's like how many square feet, how many plants, this is what you need. So yeah, I mean, it is very much like Legos. Unfortunately, it can be convoluted because of the knowledge base that's necessary behind it for specification.
Yeah, and I'm sorry, I had one more question about that photo before. We can't see, we can see the octobubbler, we can see the 1/4 inch tubing, but we don't see what's on the end of the tubing that actually goes in the plant.
Yeah, in this particular case, it's that's 1/4 inch spaghetti line, and then there's just these little like holders that the tubing will go in, and then it'll go into each side of the plant. I think in this application, there's 2 staples to each side, and that's what's going to keep the tubing right above the soil base. One, so somebody can go through and inspect and see the flow of water coming out, and then 2, so it kind of distributes a little more evenly around the bottom of the pot.
Yeah. Okay, great. Yeah, thank you.
So here's what we're going to review today. You can read, I'll just briefly say, so in the TOC or the table of contents, water source, fertigation, plants, irrigation in general, these were the topics. We vetted this through a lot of our customer base and asked what they want to know about. A lot of them did not want us to teach them how to clone and trim plants. They simply wanted to know the irrigation aspect of it. So by no means is this a design guide to the point where we're talking about lights, like I said, fire breaks, drainage in the ground, and substantial buildings. If you need to know more about that, please get a hold of me, or we can point you in the right direction. But this is simply to cover the irrigation aspect of growing plants inside.
Yeah, it's really interesting that you mentioned that, Michael, because this is one thing that I am, as I research this subject, I'm overwhelmed at the amount of information, the time, and the website dedication of lighting that goes into cannabis. And while I know it's important, I also think the water requirement is maybe equally important or not that much less important. Yet I see very little information on irrigation and mostly lighting. It's really incredible to me.
So I could talk about that for a long time, but I think with lighting, there's a lot of precautions that are on a full legal site. If you look at some of these rooms, a lot of what goes into it is not just the lighting itself and the safety of it, but the permitting process is extensive for growing inside, especially having this amount of light and this amount of power. The fire situation can get bad really fast. And so a lot of it is just precautionary. So with the lighting comes all that added, kind of structural things you need to look into and efforts. Whereas on the irrigation side, once we've provided water to the plant, most of it is getting eaten by the plant. The plant's eating the resource we're providing. So these stationary components that we're designing and putting into a room most of the time, once installed properly, aren't going to require kind of the safety initiatives that are required for something like lighting with the fires and whatnot. So we're fortunate to be, hopefully, like you said, where we can kit this out and provide small amounts of information to help people, so they realize that it's not hard to irrigate properly.
Yeah, and I'm really glad you brought that up because I do see a lot of electricity. I think wires, I can't imagine what the electricity requirement is. I also know that water and electricity don't mix very well together. And I think about this, what do they do for, if they have a problem, if they have a line break or something breaks and there's water all over the place and they're not around, what do they do to protect themselves there?
So I mean, the permitting is not going to let I know you were kidding, but with the irrigation of the water, it's so separated that everything's in the walls. I mean, they've it's worst case scenario that they've designed for most of the time, from what I've seen. To get a permit on a site like this with this amount of like BTUs pumping, that water's not getting anywhere near it. I'm sure there's a clause in the electrical aspect of it that says no overhead irrigation, which we don't have to worry about. But our water is going into the trays and it's going into the drain and then it's leaving the building. So it's never going up. I know the fire sprinkler aspect of it is a little bit more complex, because now you're trying to cool off something that's hot 18 hours a day. But as far as break control for irrigation, one of the main things that we're trying to do is control nutrients, not just water. And nutrients are very expensive, much more than water. And so if we have a break, not only are we losing water, we could potentially lose a barrel of nutrients. And this goes for outdoor growers as well. And so, that's the main reason you want to kind of centralize your control system, because that way, if you have a break of some sort, it's going to shut the system down and not only allow you to water consistently, but it's going to allow you to shut the system down in a break, event, as we call it. And there's an ancillary item to an irrigation control you need, called a flow sensor, that we use in landscape and ag all the time. Any grower growing something inside and moving that amount of water should always have some measurement of safety, which would be a flow sensor and a master valve at this point.
So just to understand correctly, the flow sensor senses high flow and then just shuts everything down?
Yeah, you set up the parameters through a learning period where you allow the controller to run through each zone. It measures the flow in each zone and it sets out as a precedent. So if it sees, a 10% drop below it or 10% above it, it's going to shut the master valve down. It's going to maybe run it for a split second more and then move on to the next valve. And in doing so, if you have 15 valves and you have a leak on one, it's not going to shut the other 14 or deprive them of water. It's going to keep moving on. And so the parameters are easily set in most controllers.
Wow. Is this expensive? Is this something you're going to have to shell out a lot of money for?
So what flow sensors are, and the capable controllers, they range. You can get smaller residential controllers that will do it, but what's going to happen is it's going to see a break and it's going to shut down. So the complexity of how it reacts to the flow alert is going to be different. So like I just said, a controller will move on to the other 14 stations. The more simple versions will simply just see a flow alert and either shut down and skip the cycle completely. So if you don't look at your controller for a couple days, it could be plants or turf dying before you even realize it. Where a more complex, expensive, valued controller is going to send you alerts, alarms, and then it's also going to provide reporting and stuff to account for your fertigation usage.
Yeah. So we might be talking for the better systems, a few $1,000 investment in something that might be my $1 million crop.
Yeah, I mean, the value of a typical cannabis or hemp plant is thousands of dollars. So the ROI is not as complicated, complex as when it comes to landscape, where you might have to fit everything into a 16-month window to get your money back. In hemp and cannabis, if you're doing anything properly, in the projects I've been a part of, your ROI should not be more than 8 to 12 months if you're cropping every 65 days.
Yeah. Okay, great. Thank you.
So as we mentioned, as typically when I want to review a system, we'll start at the point of connection. And one of the things that with hemp and cannabis and with the irrigation system in general is it is a micro irrigation system, so our orifices are very small. The odds of something getting clogged are definitely always going to be there, regardless of water quality. So I typically like to start with a water test or with some form of to let us know how much acid it is in our water. So once you determine exactly how you're going to get your water, in this case, we mentioned some utility private well and reservoir aspects. Bacteria is going to sit on the top of the water. So at one point it could interact with the system. So we want to make sure we're filtering at the right points, and we're going to figure out how to do that by first figuring out where our water is going to come from. And secondly, one of the number one questions we get all the time is, just like, how many heads can I get on a valve? How many octobubblers or how many, pieces of tubing can I have coming off my manifold or my valve, determined on the plants? And the first thing I tell people or ask people is, I need to know the the mass and I need to know the energy behind it. In this case, the mass would be the gallons per minute, which is our water, and then the energy would be the pounds of pressure. And so once we have some idea of the mass we're trying to move and how far we're trying to move it, it makes it a lot easier to figure those other things out. And an easy way to determine this, as funny as it is just fill a 5-gallon bucket up with the timer and see how many times you can fill it up. That tells you your gallon per minute. And so once we have our gallon per minute, that combined with friction loss, which is tied more to pressure, which is how much water we're losing as our water moves through our pipe, that's how we kind of measure exactly how many outlets we can put on a valve. And I'll cover that briefly here in a little bit, and I can always follow up with emails and questions, because that is the number one question I get, is from a design perspective.
Yeah, so it's really just math, right? It's just plugging in the numbers and going through the formulas.
I mean, there's a friction loss chart that exists, just like something, it may be in the Farmer's Almanac, but I mean, we stick to with biblical proportions. And rigid PVC, flexible PVC, vinyl, poly, these things, they have different friction loss. There's an amount of friction, like a splintering inside the tubing. If you look at it at a microscopic level, that just slows the water down. And so the further we move it, the more water we lose. Not necessarily pressure. We do need some pressure, but pressure is the one that everyone's always got way too much of. These small systems do not need 120 pounds of pressure. They don't need the 5 horsepower dab pump for 8 octobubblers. So everybody's always like, I have so much pressure. And it's like, that's not the problem. Usually you have way too much force and not enough mass, which is our water in this case. And they're trying to move very little amounts of water through a small amount of tubing, or a big amount of tubing, big diameter. With way too much pressure, and the octobubblers and pressure compensating manifolds just don't respond to that inconsistency very well.
Yeah. So this is interesting. I'm reading ahead, sorry, but I'm thinking, yeah, most of this is municipal water for cannabis, right? A lot of these indoor growers are using municipal water that has chlorine in it. So what are they using to take the chemicals out?
So yeah, in this particular case, reading ahead, yeah, there's reverse osmosis. So I mean, they're breaking down the water molecule to make it easier to filter out the contaminants that they don't want in it. On the secondary side of an RO system, there's typically some form of filtration. They're going to get the water as stabilized as possible before a grower is going to introduce any nutrients and fertilizers, stuff like that into it. They're going to get their pH, their acid levels dialed down to where they want them, and then they're going to start fertigating from there. So I mean, getting back to a 0 point is usually the starting point, and then as you can see in the bottom part, they're gonna introduce nutrients to it through a fertigation system. Yeah, which is a combination of what we call blending. And then, as I mentioned earlier, sampling of the water, getting tests done. Most municipalities will do this. And you can get your water tested, and that's going to provide you with exactly the information you need. And then it's just, kind of, as you alluded to, is then you're just trying to reverse that process and get the right amount of nutrients in.
Right. So I have a question here that's coming in, and they're asking, are a lot of growers using the wastewater, treating it, and putting it back on their plants?
So once water runs through the bottom of a tray, out the bottom of the plant, out the bottom of a tray, first, there's not that much water. I mean, even on that opening site that I showed you, 12 rooms, they're not even filling a 5-gallon bucket every week. So if you're watering properly with the right medium and the right amount of water, you shouldn't have so much runoff that you're needing to recycle it and put it back in. I mean, so very rarely do I see a site that is, trying to really do that. Now, I know they used to do that years back, because if you had water running out of your house all the time in the gutters, the cops might come knock on your door. So I think I deal with a lot of old school growers that used to try to reclimate their water, but you also now have something that has no nutrients in it, because hopefully your plant has sucked the nutrients out of that water, and you've got to kind of send it through the process again. So it goes back to our ROI. Is it worth it to do it? No, not usually. I mean, it's just from just what I said. Not to mention, you're going to need some form of secondary pump that's going to push the water back to the supply source, refilter it, and then send it back out. By the time you're done, what did Valley Crest guy always say? You're stepping over a penny to save a dollar, or stepping over a dollar to save a penny. So I mean, it just doesn't really make sense to do it. Now, if you have a site where you're very strict on water, and you can come to me and say, I have thousands of gallons that are just pouring into the soil. The first thing I'm going to say is, why do we have thousands of gallons pouring into the soil? Before I say, what we should do with all this wasted water is send it back to the top and start the process all over again. So.
Yeah, I think that's an excellent point, Michael. If you're applying it correctly, you shouldn't be wasting it. So, yeah. So why pump it? Why pay for it to waste it and then refilter it and pump it again? And yeah, economically, it just makes no sense.
I'm sure there's vertical farmers out there that would argue, that are completely inside, that are doing that, because if you have the capacity and the resources to do it, there is a way to do it. It's pretty high. You're talking substantial vertical farming where all the water is moving down through it, they're catching it all, and then they're sending it right back into the system again. But like I said, usually when I see a system that has that much runoff, my focus is not reusing the water. It's why do we have so much runoff? So, but I do know there's ebb and flow systems and flood systems where people drown tables, and they'll drown, sponges and rock wool with it. And then they'll just, so it's more of an ebb and a flow system. And if that's the case, we can talk offline about it and we'll figure something out. But that's my point of view.
Yeah. So, and then you've got fertigation set up here, the Maisie fertigation setup. Love this. It's what I use in my own garden. And I can't believe how well and fast my plants react to it. Is this a typical setup that you're seeing?
Yeah, so this goes back. The reason I start with this is it's essentially the basics. It's what we call venturi suction, and so it's using the energy or the pounds of pressure, the pressure that's running through the tubing in the irrigation system. It's just using those to suck a nutrient or a liquid out of a tank, and so it doesn't require any secondary source of power. So you don't need another pump. Now, the benefits of having a pump and having, as you saw in the image of this right here. The reason this little like display or interface on the wall, that's controlling the amount of nutrients that's running through it. So now if you do have a secondary pump as your irrigation is watering, you can supply a parts per million down to each gallon or down to each millionth exactly how much nutrients. So it's all about controlling. So if you do want to put a pump or something secondary on, you're going to be controlling a little more precisely. I'm sure there's some venturi suction fans out there that have no problem using these perfectly, but as we've kind of alluded to a few times, you want it all to be automated, and this is going to be a little bit more basic of a system. But I think growers need to know that this option exists, because, like you said, I think it's underused in gardens and landscapes. If it's installed properly, I think it follows the same plight that a lot of drip irrigation design does from the 90s. Which is it was installed improperly, or even in the 2000s. And so people don't think that it works. I think the same is true with fertigation systems on landscapes. I think they were usually installed above ground in hot areas where they can become brittle and they break apart. And then they required way too much maintenance because they weren't consistently maintenance. And I think if they're installed properly, like the one at your house probably is, because it's been years, then I think they're a great solution.
Yeah. Yeah.
And then beyond that, we talk about, like I said, the automation aspect of it, and then ultimately using nutrients. As I've spoke about it a few times, that one of the number one concerns when I go into a site is usually the giant tanks of nutrients that have to be used at a certain time, or they have to be stored properly. All these things, sometimes you can only store a certain amount depending on your local permitting. So all these things come into play, and these are all things that you want to take into account before you even begin to think about growing or building anything out. Is, where am I going to store these nutrients that are of such high value, and I need to take care of, and I also need to distribute in a certain amount of time. And so one of the things that we've been asked to touch on is the use of nutrients in the storage. And like everything in here, these are essentially cliff notes, and that we can expand upon them. Always just, we can follow up with reaching out to each other. And then as I mentioned, nutrients, very rarely do I see high amounts of nutrients stored for a long period of time. Not only does it make fiscal sense to buy so much in advance when you don't know the fluctuation of the market, but also because the storage and the footprint and the overhead that exists from trying to store these valuable nutrients. And so typically, there's distributors and systems of delivery that will bring the growers the tanks and the nutrients they need when they need them, or they can go into, some local retailers will deal in high volume tanks. Mostly what we're dealing with is commercial, so you're going to see the 50-gallon jugs full of nutrients. In this case, I think there's 8 of them and then an acid stabilizer, and so you can see that's the ideal circumstance for the nutrient to be stored and distributed. Media types. This is another big one out there for discussion. Depending from an irrigation standpoint, we are aware that there are different medium types. Where a little soil staple might not hold our 1/4-inch tubing in. We do have solutions for that. Anything from a mini tree ring that will go around and stick into rock wool a little bit better, to micro drippers that will just hang on the side of the pot. So we've got a solution for every kind of medium, soil, pots, bags, anything you're putting it in. And so we did want to briefly mention some of the media types that we come across and that we've designed our products to irrigate around. It is open for opinion on how people like to see their root systems grow. So some people cycle in between the different ones throughout the year just to mix it up depending on what they're trying to grow. But we are aware that there are different media types and that our products meant to water them all effectively.
Yeah, there's a lot of choices here, and everybody has their own secret sauce, right?
Yeah, and I think the best thing about hemp and cannabis growers is they're always trying to perfect it a little bit more. They're always open for discussion, and they're always trying to figure out the next thing. So, very rarely do I come across someone that knows nothing about irrigation. They usually know more about the components and less about the design and installation aspects of them. And so that's why it's an easy conversation to have. It's help that's wanted, because they really do care about the finished product as opposed to, somebody that might be mowing grass that just doesn't really care or have that kind of passion towards it, like a lot of our hemp and cannabis growers do. And so, I talked about it earlier, just the rolling benches and the way that those work and the reason that they do that. And, that's to centralize the light in the middle of the room. Lighting and fixtures have to be a certain amount of distance off of the walls, unless, they're side lighting and built appropriately. And to do that, we're going to slide all the benches in. You can slide them apart when you need to maintenance or harvest them, or you can slide them in during the grow period to harness all the light that's coming from the fixtures above. And so we noted that there's a couple different options on here. Rolling benches is what I explained. A fixed table is just simply that. You're not going to be sliding it. You're not going to be moving it. Typically, people are going to make them light enough that they can still manipulate them and move them around a grow area. Inside or out in greenhouses and hoop houses, they're still putting them on cinder blocks typically. So when the plants are not on them, they can move them and, kind of move the room around as they need to for maintenance. Rolling racks are a little more sophisticated. This is what growers are using to grow a lot of things. As you've seen stock photos from like the Netherlands and whatnot, where you're talking 15 levels high, and the benches themselves slide like library books. This is not a cheap process, but it is optimal.
Hey, so I once heard that this is one of the myths, right? And I don't know if it's true or not, but I once heard the table sizes were 4 by 8, and that became the standard size because that's a standard size of plywood that you get at Home Depot or Lowe's, and it was easy to buy and it fit in your truck.
Yeah, I mean, I'm sure standardization and consistency, as we've talked about, and as we deal with our customers and our distributors. Even the tables that are 60 feet long are still only typically 4 or 5 feet wide. Also, you want to be able to reach across them. So that's one. I mean, you don't want anything in the middle where you have this void you can't get to. The whole idea is if it's 4 feet, most people have a 2-foot long arm. They can reach to the middle of the bench for maintenance. And so you don't want it any wider than that. Any longer than that also, most permitting doesn't allow for a room with that amount of lighting in it to be a certain distance longer because they want to be able to move their fire sprinkler water around properly. So some of it has to do with permitting. Some of it has to do with just the general footprint. You can only grow so many plants so close together and then only yield them so quickly. But typically 4 by 8 is for the smaller grower. They're going to put some of those together. On the larger end, it's usually, I think, and our friends at IDC could probably attest to this. I think it's about 4 feet by 42 feet, 4 feet by something in the 40s. I've seen them up to 60, but by that time, if it's rolling, you can't even roll it because it's so heavy. So they also are only going to be about 42, 45 feet times 4. That way, if they're rolling, one person can roll them. If you got something 60 feet long, it's going to kind of worm and it's going to be difficult. So I think a lot of it's designed around those aspects.
Yeah. One thing's for sure that I'm learning today, I'm learning a lot. One of the things I'm learning is there's a lot of variables here. And I'm sure glad I have this guide to reference back to help me.
Yeah, and as you go through and look at the subheaders, if there's anything that you have more questions on, you can always reach out to us. But more than anything, this is to just show that we have the knowledge, and it goes deeper than this. So even if it's not irrigation and it's just growing practices or RO systems or injection systems, this is stuff that if we don't know everything about it, we'll be the first to send you to the people that do. But we just want to be that complete system solution source. So we mentioned some growing practices. Plants per room is going to be a lot of times up to the grower. More than anything, we're going to help you get water to all the plants, and we can provide any solution you need for that. When it comes to multi-port manifolds or cloning misters or anything like that, we're going to get water where it needs it. And those are a few that we mentioned here. Ebb and flow is more of an old school technique where they're going to completely drown the plant for 3 or 4 inches in the rock wool or the sponge, and then they're going to eliminate the water. It's a little harder to distribute nutrients this way. It's a lot of wasted nutrients unless the plants are installed perfectly. So it can be a little more difficult. Mini PEP line, point source emitters, and multi-port manifolds are something that we're experts at, which is ultimately moving water from a single source to the plant's base as efficiently as possible. And so we show you some visuals here, and we can elaborate on this extensively, obviously.
So, Michael, one thing's for sure is when I've written something, you learn the subject inside and out, and you learn the document inside and out. So we have that unique opportunity today to ask you, the creator of this this design guide, of how, if you were starting, or even if you were already had some experience irrigating cannabis indoors, how would you use this guide?
Well, I think the layman or the person that's just trying to figure out whether or not it's something they want to do, they're going to go through and they're going to assess whether or not this is the undertaking that they want to take on. Like you said, there are a lot of variables, and I think a new grower is going to take this on, and I don't think that they're going to get very overwhelmed by this. I think these are going to be a lot of things that they've already encountered. I think it's going to help them to know that other people have to deal with these issues, and that there might be factors in that maybe they didn't take into account that make coming to a solution or a conclusion a little bit better. And then I think the more substantial growers and our commercial growers that are out there, once again, maybe it'll raise questions that they haven't really thought about. Or you're always learning something new. I wasn't fortunate enough to know everything in here. I had some help from our different our teams, and so as I reached out to them and put it together, I learned definitely some new things. And there's still a lot we don't know. There's a lot of uncertainty, but all we can do is travel out to these sites and help these guys, and then try to put it on paper the clearest way possible for everyone to understand. And so I think the more complex growers will hopefully get some brevity out of that.
Yeah, good. Thank you.
So I think we're wrapping up here for the most part. We do provide ideal water amounts. We provide a plant factor. You're going to plug that into the formula, and we're going to tell you exactly how much water each plant needs. And then this is going to help you allocate exactly how you're going to get water to it, how much water you're going to put in your individual hydro zones. So I think the K factor, you can elaborate on that extensively as well. Filtration, we opened up with this. This is, to me, is one of the most important parts of an irrigation system, no matter what you're growing. And that's to make sure your water is clean and clear of debris. Debris is the number one issue or challenge we have with micro and drip irrigation. We're dealing with very small holes, and those small holes get clogged. And when they get clogged, we don't want to lose a plant. If 2 holes get clogged, we could potentially lose a plant. If all 8 on a octave get clogged, we can lose 4 plants, potentially 8 plants. That's a lot of money. And so we really want to make sure that everything on the secondary side of our valves and our filter is as clean as possible. We do this by using filters on the primary side and flush valves on the secondary side.
Yeah, so Michael, certainly if I find, and I find them pretty easily, a person using the Jain Spin Clean filter, you can't get them to use anything else. And why is that?
So a typical Y filter, the reason we have a patent on this particular style of filter is the water goes in, and as it goes in through the screen filter, it creates a vortex in the middle. And so it's essentially self-flushing. And so every time the system runs, what can typically happen in a debris basin on a Y filter is when the system's done running, if no one's there to flush it out, that debris just sits in the bottom of the basin. And then when the system goes on the next time, it just pushes it all right back into the system. So it's almost like a partial filtration, where ours is what it's going to do is, as it's running, this vortex is going to push the debris through the screen and it's going to flush it out the end of the system. And so it's constantly staying clean and self-flushing. So on top of having the option to manually flush it, it's going to try to keep that screen clean to the best it can the whole time it's running. So it's clean, it's self-cleaning.
Yeah. Oh, that's great. Thank you.
And then steel filters and disc filters. We talked about this on the hemp webinar a couple of weeks ago. There's a time and a place to use each filter. Disc filters you want to use when typically you're growing outside, where you're going to have organic or algae buildup. Screen filters you're going to want to use when you're dealing with debris. Flushing on this big system here, they're flushing the system every time that they run the system. So it comes on for about 10 seconds. And right below it, they have these 5-gallon buckets. And as I mentioned before, it takes about a week or two to fill those up because they're not wasting that much water. It's just flush water that's coming out of that system. The reclamation of water is the page we're still working on, because I'm trying to get some details on exactly how we want to explain that. But that will be in there here in the next couple of days when we release this document fully. The other number one question is, where are we at on time? Okay, perfect. The number one question we're at on, I get is, how to size my system, my pump. As I mentioned, we're ultimately trying to move water from one point to another, and we need pressure to do that. Pressure is typically the one thing I see that is never an issue. There's great pump suppliers like Leader and Dab and these different companies out there. They're designing these pumps to turn on and turn off when the pressure needs to be there. I think the focus should be, how many plants do I want to grow? Work your way backwards, and then figure out how much water each plant needs. And then we know exactly what our demand is, and we already know we have the pressure that'll push it. So once you figure out that water demand, that's the first step. So as somebody that helps people design, and we're not a design group, but we can help with the specification of the components, the first thing, those are the questions that I ask is, I know you have plenty of pressure. That's very rarely an issue because you're using pressure compensated devices like point source emitters and octobubblers. So we know that as soon as you're between 25 and 40 pounds of pressure, those devices are going to stabilize what we need. But if they don't have enough water going to them, that's going to be a different problem. So your reservoirs constantly have to be full. They have to be heavy enough that the water is pushing down and filling the pump fast enough. And so usually flow ends up being the issue. And so I've put a couple of key items to consider here. Once again, like I said, gallons per minute or flow, how to break up a zone. Once you deal with your plants and your zone's demand, if you have 50 plants in a room and each plant uses a gallon of water, then you need 50 gallons per minute. It needs a gallon per minute, then you need 50 gallons per minute. Well, right there, you know your demand, and you know you're going to lose some of that to what's going to go right through the root base and drain out the other side. And so once you figure out your water demand, it's very crucial because that's what's going to help us with the hydrozoning. And then lastly is friction loss. A lot of people want to size pipe down because they're under the impression that as the pipe gets smaller, they're increasing the pressure. That might be true at a very small level. The main reason we size pipe is because we want to save money on pipe, because pipe doesn't need to be any bigger than it needs to be, and it costs more the bigger it is. And so typically when I was zoning out a system of 60 to 80 pop-ups, I was narrowing the size of the pipe to save on money. Anybody could just put 1-inch pipe for 60 heads and then just increase the pressure. If you have a blowout of some kind, it's going to be way worse. So there's a reason we size pipe, and we do that and figure that out through the friction loss chart, which as I say this out loud, should probably put in this document, because the friction loss chart and the water demand chart, if you come to me with those two things and you know those, I'll help you all day long. It's the ones where they're always coming back to me that they have 60 plants dying, they can't get water to them. And then this is like, a $200,000 operation in the back garage, and they've already done it all and they have these problems. So always come on the front end with this kind of stuff. And, I'd love to help.
Yeah, so Michael, we've been getting the same two questions now about 10 times. And so I want you to answer this. So one, the first question is, where can I get a copy of the guide? And two is, how much does it cost?
So the guide, so I'll give you my home address and you can, I take Venmo. No, the guide's gonna be available digitally online. And then if somebody wants a printed copy, they can just email us and we'll send them a copy. We'll probably include a product guide too. And you can go through and take a look at the components that you think you need. And, I have, when this goes, when the recording goes out, I'm pretty sure my email will be on there, Richard.
Yeah.
So people will have a way to contact me, probably my phone number as well. So I can help you with all of this stuff. But hopefully just read through this, come to me with the right questions. That will expedite the process big time, which is one of the main reasons this document exists as well. And so the last couple of pages, if I could, can I finish these last two, Richard?
Sure, but I just want to confirm that if I'm really a grower and I'm just getting started, or if I've been growing for a while and I have questions, I can just email you and call you and you'll help me out.
Yeah, of course. Yeah, I mean the idea is we're looking for any opportunity to supply the right solution to a grower. Ultimately, we're going to push you back to our distributor network, and we're going to hope that you become a great customer of theirs. But we're going to work as the manufacturer and the designer of the product to make sure that you're ordering and installing the right product properly. This is all free of charge and just in exchange for buying our product, as it is in most of our markets. And then, you go through one of our certified distributors, which is who sells our product. So those two things, they go hand in hand. But yeah, the value is, you're not just spending a couple bucks on a product, you're getting free support. So if you're not capitalizing on that free support, I don't want to hear any arguments about prices. So.
All right, good point. Good point. That is the value.
And then lastly, we touch on mainline design, which I think runs in parallel. Well, not really in parallel, but in the same ballpark as the friction loss and the other things we talked about. So I can help with mainline design, which is our primary source of water off of our pumps. And then our secondary side, or for the most part, would be our zone valves. What size zone valves? How many emission devices can I put on a zone valve? How much tubing and pipe can I put on a zone valve? All these things are covered here. So that this should hopefully explain a lot. Between this and the hemp design guide, anybody that wants a copy of this, we should send our hemp design guide to as well. I think they work side by side for outdoor and indoor applications. Yeah. Excuse me. And then lastly, the control aspect of it. If we can automate this, that adds consistency and makes everything a lot easier. This is what we install our flow sensor to, and this is how we turn the system on and off. So, it's a combination of the hydraulic aspect with our valves, and then with the electronic aspect with our control systems. And this is something that we provide manufacture all of these things. So given the site variables, I can help you specify these components.
Yeah, and I always think about an article I read about hand watering cannabis. This was a couple years ago, and the person said, hand watering a few thousand plants is really boring. And sometimes I get thinking about other things. And sometimes I can't remember if I put water on that plant or not. And sometimes I double dose them and sometimes I cheat them. And it becomes apparent after a while when there's these problems. And so I think the automation of the water is so important.
Yeah, it is. I mean, very rarely do I come to a site twice where they go from hand watering and continuing to hand water. I mean, I think everybody ultimately knows they need to be switching over to the automated aspect of this. And there's just a lot of apprehension because they don't know the variables involved in the design, and then they don't know the product variable or the product solution. So there's a lot of choices out there, and me and most people out there know me, that if we don't have the right solution for it, I'll point you in the direction of one that I do think will work. And then that's the value of like a certified designer or somebody, like the IDC group, where they're going to make sure that they follow through with the design and make sure that you get not only the right products, but the right contractor to install it and follow through with the whole process. And so, like anything, do it right the first time. And within 12 months, you'll be making money. Do it wrong the first time, then it's going to be 2 or 3 years, where you're just going to give yourself a headache. And so, yeah, it's worth that little bit of extra capital up front. Irrigation is not super expensive when we comes down to the permitting and then the lights and some of the fire stuff you have to do. So do it right the first time, and reach out to us.
Boy, really good words of wisdom there, Michael. And Michael, thank you for a great irrigation design guide. We really appreciate it, and especially appreciate you taking us through this, as well as volunteering to help anybody who needs some help with this. So thank you to everybody who's watching today. We certainly appreciate your time and hope that we're hitting the mark with our education. Want to mention we're going to be dark on Friday and Wednesday of next week due to the Labor Day holiday, but we'll be back a week from Friday with Chris Savarese from Corona Tools. It's really interesting what's happening right now in the grocery store industry. We're seeing Ralph's and Safeways and places like that expanding their floral departments and getting more into gardening. Now, I think for a lot of our distributors or maybe an Armstrong or a Home Depot to think that they'd be in competition with their local grocery store for horticultural products it might be a surprise. Chris has a lot of insight on that. We're going to review that. So look for that a week from Friday. So again, thank you, Michael. Thank you, everybody. Remember, all our trainings are on our website at jainsusa.com/trainings. And everywhere you listen to your favorite podcasts, you can find us there as well. So thank you, everybody. Have a great long weekend and appreciate your support. Thank you.
Thank you.